Hello everyone, this is Brainy Ghost, and today we're gonna do a point to line collision or intersection. So first, this is my constructed. Let's try if this is working. I already compiled this thing. So we're doing two methods here. Two methods of colliding this point onto this line, as you can see. When this when this point turns red, it means that this point is colliding with one of the points of this line segment. Once we go here, no collision. Go here, no collision. Go here, collision. Alright, so let's reconstruct this. Alright, let me explain the algorithm that we are going to use here. First off, get the length of the line segment that our point is going to intersect, also its endpoints. Let's name this line segment ln1, then get the length of the line segment starting from x1, y1 endpoint and the point that is going to intersect ln1. Let's name this line segment ln2. Next, get the length of the line segment starting from x2, y2 endpoint and the point that is going to intersect ln1. Let's name this line segment ln3. Then get the length sum of ln2 and ln3 and then compare it to the length of ln1. If they are equal, then the two lines connected to the point are perfectly aligned to ln1. Thus, ln and ln1, ln2 plus ln3 are the same line. The point that we wanna intersect on ln1 is part of ln2 plus ln3. Once ln1 and ln2 plus ln3 become the same line, then it means that the point intersects ln1, or the point collides with one of the points of ln1 line segment. Open this. This file can be downloaded and the link is in the description. So, alright. What do we have here? So, mouse point, the dot, or the physical representation of this mouse point 2D, or the end points of the stationary line that we saw in the demo program. And yeah, that's all. So first, compute the length of ln1 line segment. So this is the computation. Then next, go here in the update data and we are going to put some codes here. So put this in your code. So endpoint 1, the distance, endpoint 1 to mouse point distance x, and then endpoint to mouse point distance y. So this is the line segment between the first endpoint of ln1 and the mouse pointer. Alright, compute the distance. Put this in your code. So this thing, this code snippet computes the line segment between the end, so the second endpoint of ln1 and the mouse point. Alright, then next, put this in your code. So get the sum of this, of the length of these two line segments, and then put this in your code. Compare the sum of these two line segments, their lengths, and compare it to wait, forgot to put the offset. So yeah, create an offset. I'm going to explain this later. I'm going to comment this. Wait a minute. So yeah, remove this for a moment. I'm going to explain the purpose of this offset later. So yep, so get the sum and compare the sum with the length of ln1. And yeah, wait, going to remove this. We just need this equal. So if the total length of these two lines is equal to the total length of ln1, then these two lines combined are equal to this, to ln1. Thus, the point that is part of this lines collides with one of the points of this line segment. And yeah, let's try this. So compile and run. Why? Think be weird. Yeah, I got the spelling wrong here. Should be never mind. Alright. So let's see if this is working. Yeah, this is hard to, as you can see there, there's the point here, the mouse pointer was blinking red. Let's see, it's hard to make a contact with one of the points. And yeah, I got contact, as you can see. So this point, the mouse point, is colliding with one of the points of this line. Now let's use the offset to make it easier to collide with this line segment. Alright, so yeah, go down. Going to change this now to this and uncomment this. So this offset increases the range of its collision, or its collision distance with the mouse point. So yeah, if the sum of both of these line segments are greater than this and yeah, less than this, so there's a range here, then its colliding is true, else it's false. And now let's try this, compile and run. Let's see if this point will collide easily with this line segment. And yep, as you can see, the collision distance between them has increased, and yeah, they are colliding well. And that's all for this method. Alright, let's do the second method. So this is my constructed program. Let's try if this is working. Let's see if there's a collision. And yeah, there you go, there's a collision. And once I move here, no collision of course. Just want to collide with the line segment, with one of the points of this line segment. We don't want to collide here because the line segment ends here. So yep, so this is working. And let's reconstruct that program. Alright, I'm going to explain about what we're going to do in this second method before coding. First off, you must have an understanding of line intersection that I explained in my previous tutorial. Now, we have a given line segment with two endpoints and a point. With this, we can use a theorem of line equation that states if there's a given line and point, then there's a line that goes through the point, and that line is perpendicular to the given line. I provided a resource about this theorem in the description. Now, we have two lines. Let's name the given line line A, and name the perpendicular line line B. We needed to get the slope of line B, but we only have one given point in line B. Nonetheless, there's a way. In linear equation, if a line is perpendicular to another line, then the slope of the line that is perpendicular to another line is -1 divided by the slope of another line. I provided a resource about perpendicular lines in the description. Now, we can solve for the slope of line B because it's perpendicular to line A and we know 2 points in line A. Thus, we can get the slope of line A. After that, we can make a standard form equation of line B by using its slope, then use Kramer's rule to check if two lines intersect and get the intersection point. I already explained this in my line intersection tutorial. Go watch it before watching this tutorial. We are intersecting a point to line A here, so we need to check if the point that we wanna intersect is collided with the intersection point, which is a part of line A. If they do, then the point intersects line A. I'm going to close this, open this, can be downloaded, and the link is in the description, and this also. So let's see what we have here. So mouse point, mouse dot, I already explained this. Now we have this intersection point. This intersection point was the yellow circle that was on the line segment that we saw in the demo program. So yeah, go here and then open this line.java. This line is the program that we created in the line intersection tutorial. So I hope you still have that code, because we're going to copy this, because I don't wanna type this again, it's tedious. Alright, copy this, and we can close this thing now and put this thing here, and we're going to do some changes like this. We're going to change this. Wait, so yep, delete this and put this in your code. So instead of a second line, we're going to use the point of the mouse pointer. Then what else? And then delete this. We don't need this, and change it to this code. So yep, since the line, there's a line that goes through the point, and that line is perpendicular to the line of our given line segment. So if this is perpendicular to this line, then the slope of this line, or the A2, is 1 divided by the slope of this, and that's how you get the slope that is perpendicular to another line. And then yeah, nothing to change here. And what else? We need to remove this. We're going to change this to this and remove the offset for now. And yeah, remove this and this, and realign, and yeah, what else? And put this in your code. So we need to color the intersection point to appear on the screen later. So yeah, we change this. So first, we want to make sure that the intersection point is in the range, is on the line segment, ln1 line segment. If the line that is perpendicular to ln1 intersects the line segment, or ln1, then go here, set the intersection point, and then check if the intersection point is change this to this. So let me repeat myself. So if the intersection point, or the x dot and y dot, are equal to x3 or x3 and y3, or the mouse point, then one of the points of ln1 collides with the mouse point. So yeah, we can try this. Alright, no errors. Oops. And let's check. As you can see, the color of this mouse pointer was turning red. It's kind of hard to make a collision here. As you can see, I'm having a hard time producing a collision between these two. But we saw a glimpse that these two collided. It's just hard to do it here. Maybe here it's easy to do it at the end. And you need to increase the collision distance of ln1 to the mouse point. So that's the purpose of the offset that I removed earlier. We're going to put it now. We're going to put it here. Wait, so yeah, put this in your code. Let's try 0.5. Don't increase the offset too much, or else the collision of the collision of ln1 and the mouse point is going to be inaccurate. So just add a little bit of offset to increase the collision distance. So no, we're going to change this. So put this in your code. So now we have this range, x3 minus offset, x3 plus offset. Now let's try. And let's see if we can get a collision easily. And looks like yeah, I'm getting contact. Yeah, colliding with this line is much easier now. Alright, very good. And yeah, if you want to remove this point on the line segment, when your mouse point is not in this part, yeah, or if your mouse point is, or if the line that is or the line of the mouse point here, it's invisible. The line of this mouse point that is perpendicular to ln1 does not intersect the line segment, this green, then we can fix that easily. We can remove it. So yeah, put this in your code. Always set the frame of this ellipse to 0, no width, no height, and no coordinates. always reset this every time we go here, every time we check for collision. And let's see, as you can see, the point on the line segment is no more. When the mouse pointer is here and its line that is perpendicular to the line of this line segment does not intersect the green line segment. When we go here, yeah, we can see the intersection point. And here, nothing. And yeah, that's all for this algorithm. I hope you've learned something from this, and see you later.